All right, rate the video 2, physical behavior of matter, vocab. There's going to be 20 words. We need to find out who and what they are and get on with our lives. Temperature, redefining something we think we already know. Temperature, by definition, is the measure of average kinetic energy. Okay. I don't see heat on this list. Heat is kinetic energy. Temperature is the measure of average kinetic energy. Okay, temperature is just the measure of heat. Okay, heat transfer always from hot to cold. This is the flow of heat from hot to cold. It's a direct transfer. Okay, kinetic energy. Ooh, here we go. Watch so carefully the bar graph. I see how it's changing. Potential energy is changing as I go up, 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 and then it goes to kinetic, and then it goes up, 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 up. Ready? So this is kinetic energy is the energy of motion. Okay. And then same picture. And potential energy is now the energy of position. And it will not be on your vocab quiz, but in our case, it will also be in stored chemical bonds. Okay. Kinetic molecular theory. Check these guys out. This is what's going on in a gas. Random straight line motion, except for they shouldn't change their contacts like that. So there is 5 postulates used to explain the behavior of gases. And so that's all I'm going to put down for the definition here. When we get into kinetic molecular theory, I will state all 5 of those for you. But for the sense or for the sake of doing a vocab quiz, you need to know it's 5 postulates used to explain the behavior of gases. Absolute zero. This is great. This is 300 Kelvin and 0 Kelvin, and 300 Kelvin and 0 Kelvin. Notice all motion stops. This is a theoretical temperature which all motion stops. There will be 0 heat energy. And without heat, there will be no motion. We will learn about the 3 different kinds of motion and the fact that the desks and the chairs in the room, even though they're solid, the particles are moving. And I know they're moving because they have heat. I know they have heat because they are not at absolute zero. Absolute zero is negative 273 degrees Celsius. So we haven't really quite got there yet. Normal boiling point. Here is table H. That dotted line is 1 atmosphere. It's also 101.3 kilopascals. That was on a reference table quiz. And that is what is considered normal. STP. Okay, so this is the temperature at which a liquid boils at 1 atm. And you could also have there 101.3 kilopascals. But let's be honest, 1 atm is a little bit easier. 1 atmosphere. ATM does not stand for automated teller machine in this class. It stands for atmospheres. Cooling curve. Here's a cooling curve. They will all look like this. You will learn how to draw them. You will learn how to label them. You will learn the points of a cooling curve. This is a graphical representation of kinetic and potential energy as a substance is cooled. Heating curve is going to be the exact opposite. This one's going up, and it's got a GIF to it so you can see the different phase diagrams up top, which is kind of cool. The difference between solid, solid and liquid, liquid, liquid and gas, and all gas. And we're going to get into those. We'll probably do a little bit of those phase diagrams a little bit up top. What we're really concerned about is the slant, flat, slant, flat, slant. In these graphs, that is how all curves go. This is the graphical representation of kinetic and potential energy as a substance is heated. Okay, I'm sure we can see the 2 different words there and match them to the right vocab word. Evaporation, by definition. Okay, this is the surface of a liquid that changes into the gas phase. Evaporation does not happen at the bottom of the liquid. It happens at the surface where it is touching the atmosphere, okay, or the air. Okay. Moving on, heat of fusion. This is a constant that we need to know for solving these Q equations. Okay, so it's going to be H sub F. You see heat of fusion. Down at the bottom, you see it's delta H, so it's a change in heat. Okay, the amount of heat needed to completely melt a solid with no change in temperature. The heat of fusion happens during a phase change. Temperatures do not change during phase changes. We need to get that straight That will be a big part of those diagrams, okay? Heat of vaporization is the same thing, except for now this is, or I'm sorry, a similar thing. It's up now at the boiling point, though. Notice it's up top now. And this is the amount of heat needed to completely evaporate a gas with no change. And evaporate a gas is bad. It doesn't make sense, Milks. You're going to evaporate a liquid to a gas, is what that should say. So let's see if it says that on the vocab quiz. I do need to make that change because we don't evaporate a gas. We evaporate a liquid to a gas. Okay? Good? Okay. Delta H, notice this is the difference between the reactants and the products. Delta H of products minus the delta H of reactants. This shows the change in heat as a result of the reactions, and I need to do it that particular way because number one is subtraction, and then it helps me with the sign. A positive is endothermic and a negative is exothermic value there for delta H. So we're going to learn that too. Melting point. Oh, this is fun. This is gallium. It's a metal that has such a low melting point that it can melt in your hand. That's pretty wavy. One more time, Milks. You see it? There it goes. I don't have a piece of gallium that big. The piece I was given was only about this big. Oh, and now you can't see me. All right, so melting point, the temperature at which a substance changes phase from a liquid to a solid to a liquid or a liquid to a solid. So we're not going to we will eventually get into the difference between the direction, but that's going to be the same part on the graph, okay? And then vapor pressure and pressure. Okay, these are the pressure created at the surface of the liquid pushing up, and that pushes up on the atmosphere. The atmosphere is pushing down, and it's good. We're going to need to know that so that we can redefine what boiling is. Okay, 5 more, and I think we're done. Calorimetry. This is a PBoM calorimeter, it's called. There is an explosion in the ignition wires there, and we will test the change in temperature to measure heat. So calorimetry is the measure of heat, and we can measure heat by changing temperature. Okay. Boiling point and condensation point. It's boiling, 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 and boom. This is the temperature at which a substance changes phase from liquid to gas or gas to liquid. Another one of those points where it depends if I'm adding heat, which way I'm going, or if I'm removing heat, which way I'm going. Ideal gas behavior, blew right through that picture by accident. When a gas is at high temperature and low pressure, it will obey the kinetic theory most closely. So that's something you guys have to remember and memorize. High temperature, low pressure. We'll get into why and how to remember that, but that's the key. And for whatever reason, students have struggled with that for years. Combined gas law, there is the equation that is in your reference table. P1V1 over T1 equals P2V2 over T2, where 1 is the initial conditions and 2 is the final conditions. It combines Charles' law, Boyle's law, and Guy-Lussac's law into one large expression. Good news for you this year, we took out of the unit Charles' law, Boyle's law, and Guy-Lussac's law is separate. One's P1V1 equals P2V2. One's P1 over T1 equals P2 over V2. One's V1 over T1 equals V2 over T2. And so you take all 3 of those, you put them together, and you get that big combined gas law. Well, that's the only one we really need to use. Okay. Standard temperature and pressure. This is reference table A in your reference tables. Okay, this is the temperature of 0 degrees and pressure of 1 atmosphere provides scientists a standard set of conditions to make comparisons. Notice it says standard temperature and pressure, and there I have the word standard set of conditions. You should be able to get that one right on the vocab test every time. And let's see if I remember to get rid of the noise. Oh, I didn't. Damn notes are killing me. Sorry, guys. But it's funny. Yes, we did it. All right, see you in school.